For this demo, we're going to show you how we can use our TDC checking bridge, is what we call it, checking bridge, to measure TDC. And how you do that is we're going to start a new test. And this TDC method here, we're all doing intake centerline before. But there's two options down here, and some of these you won't see unless you got the plus version of the software. You can check find TDC with stops. Stops means piston stops. So that if you had, let's say, the system set up in an engine, you could have a piston stop. So you'd rotate the engine one way, if you selected this way to find TDC, rotate it one way into the piston stop, press the button that I'll show you on the screen, rotate it the other way to the piston stop, press the button, and the program will split the difference and say the middle between those is TDC. Another option you can use with this is if you can position the cam at exactly TDC, you know where TDC is supposed to be for whatever reason. Maybe you want to go in the engine again and go with the timing marks on the damper and put it at TDC. What you do is the same thing. You put it there and you'll say that's the first stop, and then you won't move it at all and say here's the second stop, and the program will split the difference, which will be zero difference, and it'll call that TDC. So that's another thing you can do. When we're using the TDC or the bridge, it's called finding TDC with the sensor. And the sensor means a linear encoder. So we're going to select that, and we're going to start this test with this new method of finding TDC with a sensor. Okay, we've been running the thing, and it says, do you want to keep the current index of TDC in the black box, which can be a handy thing to do. I'm going to say no, but if you were running the test on the same cam and wanted to keep, and the rotary encoder's always been attached to the cam, it has not lost its index. If it gets powered down and powered back up, it loses index. You shut the program down, start it back up, it loses index. But in the situation where I just ran something, it's saying, do you want to re-index it? I'm going to say yes, but in some cases you may want to say no. Okay, so it has no idea where TDC is right now in the black box. So we're going to go up here to record, and the first thing we're going to do is, well, hold on. I'm going to switch to our webcam here so I can show you what this TDC bridge is, and I have to put the mic down for a second. The TDC bridge is basically a way of basically turning the dowel pin here on the end of the cam, into a flat, and this is going to be our flat tappet lifter. You can see I moved the locating magnet out of the way because that can kind of get in the way. So here we have our dowel pin, and this is going to go up and down with the dowel pin, just like a flat tappet lifter would be. And when you're going to see when you rotate, you say, oh, that's moving around a little bit. Is that going to be accurate at all? And yes, it is, because of this strong angle, because we're hinged over here, and because this thing here is very flat with respect to this, it really is very precise. Generally, you're going to get repeatable measurements within 1 or 2/10 of a degree on where that dowel pin is exactly located. So we're going to prep for getting close to running our test. And what you do is, you don't want it to measure, I mean, watch this thing go up and down. I mean, that thing's going up and down, and you can see our cam is sliding off because you don't have our magnetic lifter there. It's sliding off our magnetic holder. It's sliding off the end, but this thing's going up and down about 1 inch. That's too much measurement for an accurate measurement. What you want is, you want this thing to see maybe, I'm backing it off so it doesn't hit the journal here, maybe 100,000, 200,000 lift, a 1/4 inch lift at the most. So we're going to start there. We're going to rotate through that. That's pretty close. Okay, so we're going to start right about there. Okay, and now I'm going to switch over to the program. When you're finding TDC with stops or lifter, you got this new thing set up here, finding TDC. So I'm going to click on that, or I'm going to press F4. F4 works better. Okay. Okay, after you click on OK to see this message, is telling you rotate the crank to where the position where the sensor first starts to measure it on the dowel pin. If we had a snout on this cam, we would only have a total of a 1/4 inch to work with anyway. But we got much more than that. So I've got this thing set up where I want it. So it's going to see about a 1/4 inch of travel. So it's just giving us that message. And now you can see start sensor or sensor start when we're in position and then press F5. Well, I'm already in position. So I'm going to have to turn this off because I'm not going to get good data while I'm trying to do a stream recording. So I'm going to turn the recording off. Sorry, I'm going to let you see this message first. I'm going to go F5 and then I'm going to turn the recording off. So here's F5 and it tells you what to do. To rotate the cam through the TDC location and then back down. And when it's recorded enough data, basically return to the lift it started at, it is going to say, I've got enough data, I'm going to beep at you, and then it's going to say, here's where TDC was. So I'm going to stop recording and then go through this. Okay, I rotated it and it said it found it successfully. And now it's asking a pretty important question. Was the maximum measurement at exactly TDC? Like when measuring piston movement. Like if we had the encoder on top of the piston, you would say yes, because that maximum position there was TDC of the piston. But we got to say no, because that dowel pin and most dowel pins are not located at TDC. There's something off of TDC. And you're not probably going to know it. We know it here. We've got references we can refer to. For a small block Chevy, most of them, they are 53 degrees clockwise. And that's all you need to know, 53 degrees clockwise. So I'm going to say no, it's not, that it is 53 degrees off. Click on OK or press enter. And that it is clockwise. Okay. Now it knows where TDC is, and based on that dowel pin. Okay, I just wanted to show you something here about the repeatability of this. I just did a second measurement. And if you don't close this screen and just do another measurement, the program will actually show you how close were you to your last one, how much different is it going to re-index that thing by. And you can see here it says we're going to re-index by 53.053. Now that 53 is the 53 I put in. When we, in newer versions of the program, we're actually going to eliminate that, so it's just going to have that built in. But we're off by 0.053 from the first measurement. And it's giving us a standard error measurement, which is basically saying how much scatter was in there in the data. If the data doesn't look right, like you didn't start at a good location or whatever, it's going to say, I think you should run this again, change something. And again, it's asking you, was this measurement at exact TDC point, like measuring piston motion? And I'm going to say no. And I'm going to type in the 53, press enter, and clockwise, and now I'll re-index it again. I'm going to switch over to the webcam here, show you something. Again, when you have the cams, I'm sorry, I got to put down the microphone here. But some cams don't have a dowel pin. They got a keyway. And what we do if you got a keyway is we have these very strong little magnets we can put in the keyway. And now that's pretty solid. That's going to stay there. Whoop, there it didn't stay. But if you take a little care, you can get this magnet in there, and that is now going to be your dowel pin. So when you rotate that, it's going to go up and down just like that did. And you're going to measure the peak location of this dowel pin, or that keyway, I'm sorry. Problem with doing these things on one take is I don't know if I showed you actually rotating the cam through TDC on the bridge. So here I'm going to do it again. I'm going to start the test, and this is not going to be accurate at all because I'm jumping around to too many things. But here we are, and this is what the test looks like on the screen and here. And you can hear it beeped at us when it got enough data. And this thing here is acting like a big flat tappet for this thing to be on. If this thing was bent significantly from here, and this was twisted, then you might get a little bit of air because this would be twisted at a different angle than this and such. But if this is fairly flat with this, and you can check it by just putting on a flat plate, this whole system is very forgiving. Like I showed you, we're off by 0.05 0.05 degrees, and you're going to find that that's very typical. This thing is very precise, but I thought I'd just show you how it works, and when you get done, it beeps at you. So that concludes our demo on the TDC bridge. Thanks.